If Venus is to be inhabited, it will not begin on the surface. The surface is extreme. Temperatures exceed 400 degrees Celsius. Pressure is crushing. No material system we currently operate can function long-term in that environment without extraordinary shielding. But at approximately 50 kilometers above the surface, something changes. Atmospheric pressure approaches 1 bar, similar to Earth. Temperature ranges between 0 and 50 degrees Celsius. The atmosphere is dense, primarily carbon dioxide, which allows buoyant structures to float using breathable air. Air itself becomes a lifting gas. This is the key. A habitat filled with oxygen and nitrogen is lighter than the surrounding carbon dioxide atmosphere. It does not need rockets to stay aloft. It becomes buoyant. Engineering Venus therefore begins with atmospheric platforms, not land bases. The first phase would involve robotic atmospheric probes. Phase 2 would deploy autonomous fabrication balloons that assemble structural membranes. These membranes must resist sulfuric acid droplets present in Venus's cloud layers. Materials would likely include fluoropolymers, graphene composites, and multilayer corrosion-resistant laminates. Energy is abundant. Venus receives nearly twice the solar energy that Earth does. Above the densest cloud layer, solar arrays would operate continuously with high efficiency. Power becomes stable. Gravity on Venus is 90% of Earth's gravity. This simplifies human adaptation compared to the Moon or Mars. Floating cities would be modular, each module interconnected but structurally independent. No single life support hub controlling all oxygen, no single power node controlling all energy. Distributed infrastructure prevents systemic collapse. Mobility corridors between platforms would allow controlled expansion. Transportation would rely on electric propulsion aircraft adapted for dense atmosphere. Venus is not colonized like Earth. It is inhabited like an ocean. Floating, modular, adaptive. Phase 1, robotic atmospheric stabilization. Phase 2, small-scale research habitats. Phase 3, industrial atmospheric processing. Venus's carbon dioxide can be converted into oxygen, carbon materials, and synthetic fuels. Venus becomes a planetary-scale chemistry engine. Not a second Earth, a complementary world. After the Moon stabilizes industrial production, Venus stabilizes energy and atmospheric processing. This is episode 34 of the Venus Civilization Blueprint.